Okay, let us see one more experiment. Measurement of the wavelength of monochromatic light using Fresnel's Biprism experiment. You all know about this Biprism. You already used it in your labs. It consists of two rays, the ordinary ray and the extraordinary ray. This is something like your double slit experiment where they serve as two coherent sources. So you can find the theory in your books. Let us see how you do this experiment virtually. So these are the buttons. Once again click on this VLabs here. This window appears here. Simulator, as you can see, is stopped here. So switch on this. The simulator is on. Get the optical bench. This is the optical bench. Get the light source. See, you can see two sources. There are two coherent sources, S1 and S2, which are the two rays which are emerged from this biprism. This is your biprism. These two rays which are emanated from these two sources enter the biprism. Keep the eyepiece here. Place the lens here. As before, you can increase the distance or decrease the distance, plus and minus here. And by adjusting this distance, you are able to see the fringe pattern over here. So you can here see the distance between the slit and the eyepiece. Slit and the eyepiece 630 centimeters, which remains constant almost. Distance by the two image formed by the lens at second position, and as you continuously change this distance at one particular position, you can see the position is changed. So you can see it is changing. At one particular position, you will find a fringe pattern. Keep on adjusting the distance until you find a proper fringe pattern on your screen. Once you get this, note these distances D to D1 here. The fringe width is given as 0.00023 centimeters. Distance between the two virtual sources, that is capital D, is also given here. Yeah, 630 centimeters. Distance between the slit and the eyepiece is this, and this 2D is calculated using square root of D1 and D2. D1, that is from the first lens, from the first source. This is from the second source. Use this formula to calculate this, and this capital D 630 centimeters remains the same. Repeat this experiment for different distances until you find a clear fringe pattern. Once you do this, you can calculate the wavelength from the experiment and from this formula, and see, you can compare them. So you can go once again do this. See, you are not able to see this until this point. So go on decreasing this. Here again you will find this distance. Record these observations and calculate the wavelength of this monochromatic light. Compare it with this. The same experiment you can do it at your labs also, and see, calculate, record your observations, calculate the results, compare those results with what you get in this virtual experiment. And by using these virtual laboratories, you are able to do the experiment, practice it as many number of times as